Hello everyone, this is Aruna S and my team members Mridula A, Srichala T and RS Shreya. Today we'll be presenting a project on AI-enabled attendance stream. Problem statement. Current transportation and school management systems often fail to notify parents effectively about their child's arrival at school or home. This creates anxiety for parents, especially when children commute alone or via school transport. Traditional manual systems such as attendance registers, ID card swipes, or verbal confirmations are time-consuming and inefficient, susceptible to human error or manipulation, not capable of providing real-time updates. These limitations can compromise child safety and need to provide timely reassurance to parents. The need of the hour is a smart, automated solution that ensures accountability and instant communication using artificial intelligence.
Objectives. Real-time notifications. Delivers instant alerts to parents once their child is identified entering or exiting the school premises. Improve safety measures. Strengthen safety protocols by automating attendance and eliminating the risks of proxy or missed reporting. Parental peace of mind. Provides transparency and reassurance by ensuring parents are informed in real time. Operational efficiency. Help schools streamline attendance logging and reporting without additional manual effort. Users or stakeholders. Parents seeking a reliable system to receive real time confirmation that their children has safely reached home or school. Developers or technical teams responsible for designing, developing, and deploying the facial recognition based on attendance system with a focus on security, scalability, and ease of use. Schools or organizations. Institutions implementing the AI enabled attendance system to improve operational efficiency, safety standards, and parental trust.
Data used. This project uses basic rule-based AI heuristics rather than deep learning. Keyword detection. Searches for keywords in terms like def, print, if, for, or while to infer code engagement. Pattern analysis. Determines if a submission is long enough and syntactically meaningful. Heuristic learning potential. Future versions can incorporate a machine learning classifier that learns from past active or inactive submissions for improved accuracy.
AI technique used. Rule-based AI, heuristic approach. The system uses predefined rules to detect coding activity. It looks for Python keywords like def, print, if, for, and while that indicate logical or functional programming work. These rules act as the intelligence that help the system decide whether the student has written meaningful code. Pattern recognition. The system checks code structure and length to recognize valid programming patterns. It helps distinguish between active and inactive participation. Decision automation. The AI automatically marks attendance when valid code is detected, removing the need for manual verification.
The prototype for this idea is very straightforward. We want to mark attendance only if someone submits a snippet that shows signs of actual coding activity. The script uses two checks. First, it looks for key Python keywords like def, print, if, for, or while. Second, it ensures the code isn't just a few characters long. It must be at least 10 characters after trimming whitespace. This logic is handled by a function called isActiveCode. If the code passes both checks, it's considered active. Now we have the mark attendance function. This takes a name, a code snippet, and an attendance list. If the code is active, it records the person's name along with a current timestamp. Otherwise, it prints a message saying no valid activity was detected. Now here's where the script puts it all together. It defines a list of submissions. For example, Alex submits a function with a print statement, Bob submits a print command, Charlie just assigns a value, and David uses an if statement. The script loops through each submission and calls the attendance function. Finally, it prints out the attendance record. Based on the logic, Alice, Bob, David should be marked present, while Charlie's submission doesn't meet a criteria. Testing procedure. Sample submissions were entered for multiple users: Alice, Bob, Charlie, David. The system correctly identified which users wrote active code, detected keywords and length. Attendance timestamps were automatically generated and printed. This is the output obtained for the following prototype.
Feedback. Teachers found it useful for automatic verification in coding sessions. Students liked that the attendance reflected genuine participation. Suggested improvement. Integrating code quality or execution success into activity check. Conclusion. The AI code activity attendance system provides an efficient, automated way to track students' participation in online coding environments. It detects active engagement using simple yet effective AI heuristics, ensuring fairness and transparency. This project demonstrates how AI can assist educators by automatic, repetitive administrative tasks while maintaining meaningful engagement tracking.